Hi, I am Dr. J. Suresh Goud, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss the topic chi-square test method 3. In the previous sessions, we have completed two methods in chi-square distribution or chi-square test. In chi-square test, total we have three methods. Out of three, we have completed two methods. For all the three methods, we have only one difference. The remaining total procedure is same. What is that differences? How to find expected frequencies is only the difference in all the three methods in the test of chi-square. In method 1, we are going to find out expected frequency by using average of observed frequencies. In method 2, we can find out expected frequency by using n into p of x equal to x. That means this p of x equal to x may be binomial distribution or Poisson distribution. If it is binomial distribution, the problem consists of binomial distribution. We are going to use binomial distribution formula for p of x equal to x, which is ncx p power x q power n minus x. In case if the problem consists of Poisson distribution, we are going to replace p of x equal to x is e power minus lambda into lambda power x by x factorial. Based on these two, we can find out expected frequencies in method 1 and method 2. Now we are going to discuss the method 3 in chi-square test. The formula is same, that is chi-square equal to sigma oi minus ei whole square by ei, where observed frequencies we are going to get it from the problem and expected frequency we should find by using method 3 concept. We'll discuss later what is the procedure of expected frequency. And in step 3, this chi-square alpha we can choose at n minus 1 degrees of freedom from chi-square distribution table that we have discussed in the previous session. Now, we'll go to the problems on method 3 in chi-square test. The problem description is the following table gives the classification of 100 workers according to the gender, means male or female, and nature of the work. Are they stable or not? Test whether the nature work is independent of the gender of the worker. Test the nature of the work is independent of the gender of the work. This table data is given. See, total 100 workers are there. Out of 100 workers, male are 60 and female are 40. Out of 60 male, only 40 male workers are stable. Out of 40, only 30 female are stable. Total stable persons, workers 50. Similarly, out of 30 male, remaining 20 people or 20 workers are unstable to do the work. And 30 female out of 40 female are unstable to do the work. So total 50 workers are unstable and 50 workers are stable. This data is given. Now, what are the observed frequencies in this data? This 40, 10, 20 and 30. These four observed frequencies are given. These are the total values we are not going to consider. So, four observed frequencies are given. 40, 10, 20, 30. Observed frequencies. We should find out expected frequencies for corresponding to the observed frequencies. How to find expected frequency in method 3. In method 1, we can find out average of all observed frequencies. Method 2, the problem consists of binomial or Poisson distribution. Based on that one, we can find out expected frequency. If the problem consists of like this table independent attributes, we are going to find out expected frequency in a different manner. That we are going to discuss in the next slide. See, expected frequency formula, row total into column total by grand total. Row total into column total by grand total. That means corresponding row total into corresponding column total by total. Grand total means total number of workers, 100 members. Now coming back to this slide, this is the row total 60, column total 50. To find expected frequency of 40, we should find out corresponding row total 60 into corresponding column total 50 by grand total means the total number of workers. This is equal to 30. So, this is the observed frequency. The corresponding expected frequency is 30. Now coming to second observed frequency 10. For this observed frequency, what is expected frequency? Corresponding row total 40 into corresponding column total 50 by grand total 100. This is 20. So, expected frequency is 20 corresponding to the observed frequency 10. Similarly, for this observed frequency 20, corresponding row total 60 into corresponding column total 50 by grand total, which is 30. So, the expected frequency is 30. Now, one more 30 observed frequency is there. Corresponding row total 40 into corresponding column total 50 by 100, which is 20. Like this, we should find expected frequency corresponding to the observed frequencies by using the formula row total, corresponding row total into corresponding column total by grand total. That values we have written 30, 30, 20, 20. These are the total values. We don't bother about the total values. Now, to find out chi-square value, remaining process is same like method 1 and method 2. See, these are the given observed frequencies. These are the expected frequencies we calculated in the previous slide corresponding to the given observed frequencies. Now we should do, what is chi-square formula? Is sigma OI minus EI whole square by EI. First we have to calculate this value by taking OI minus EI whole square. This is OI, corresponding EI is 30. 40 minus 30, which is 10, 10 square 100. 20 minus 30 minus 10 whole square 100. 10 minus 20 minus 10 whole square 100. 30 minus 20, 10 whole square 100. Now, OI minus EI whole square by EI, that means this 100 by 30, which is 3.3, 100 by 30, 3.3, 100 by 25, 100 by 25. These values we got it, OI minus EI whole square by EI. But in chi-square we have sigma, that means we can add all these terms, we are going to get 16.6. So, chi-square equal to 16.6. But in the procedure of test of hypothesis, we have 5 steps. The first step, we are going to set up null hypothesis. That means there is no difference between observed and expected frequencies, which is OI and EI. And alternative hypothesis, which is denoted by H1, that means there is a difference between observed and expected frequencies. and alpha level of significance not given. General, the standard level of significance we are going to take, which is 0.05. And here in step 3, chi-square alpha we can choose at r minus 1 into c minus 1 degrees of freedom. R minus 1 into c minus 1 degrees of freedom. Chi-square 0.05 at where r is number of rows and c is number of columns. How many rows and how many columns in the problem table? We have 2 rows and 2 columns. I'll show you. See, first row, second row. First column, second column. We are not going to bother about the total values. Only 2 rows and 2 columns. So, r minus 1, 2 minus 1 into c minus 1, 2 minus 1 degrees of freedom. So, chi-square 0.05 at 1 into 1, 1 degrees of freedom. This value we are going to choose from chi-square distribution table. I'll show you what is chi-square 0.05 at 1 degrees of freedom from chi-square distribution table. This is chi-square distribution table. At alpha is 0.05 at 1 degrees of freedom. These are the degrees of freedom, nothing but total number of independent variables. At 1 degrees of freedom, where nu or n minus 1 is 1 degrees of freedom, which is 3.841. This is chi-square 0.05 at 1 degrees of freedom, which is 3.841. Chi-square 0.05 at 1 degrees of freedom equal to 3.84. Step 3. Step 4 we have calculated in the previous slide, which is 16.6, and mod chi-square is 16.6, and in step 3 chi-square alpha value is 3.14 something. Now, in the last step, conclusion, according to the values of mod chi-square and chi-square alpha, we are going to compare that mod chi-square value is greater than chi-square alpha. Means, we reject the null hypothesis according to the procedure of test of hypothesis. We are going to reject the null hypothesis. Actually, what is null hypothesis? OI equal to EI. We are going to reject this null hypothesis. That means there is a difference. There is a difference between observed and expected frequencies. Like this, we have to solve the problems on chi-square test method 3. If problem consists of table format, which is nothing but chi-square test for independence of attributes, we are going to find out expected frequency by using the formula corresponding row total into corresponding column total by grand total. That is only the difference in method 3 compared to method 1 and method 2. Now, before going to do problem 2, as of now, we completed all the 3 methods. These 3 methods we are going to use only to find expected frequency. Remaining all the procedures are same in all 3 methods. In method 1, expected frequency we can find out by using average of observed frequencies. And in method 2, expected frequency we can find out by using either binomial or Poisson distribution. And in method 3, we can find out expected frequency by using the formula corresponding row total into corresponding column total by grand total. Now, this problem 2 consists of table format, means chi-square test for independence of attributes. We are going to use method 3 for this problem. The description of the problem is, on the basis of information given below about the treatment of 200 patients, about the treatment of 200 patients suffering from a disease. Out of 200 cases, whether there is new treatment is compared superior to the conventional treatment. New treatment is compared superior to the conventional treatment. We have to test. Out of 200, total number of patients are suffering with disease. And these two are two different types of treatments. New treatment and routine conventional treatment. 60 patients are favorable to the new treatment and 30 patients are not favorable to the new treatment. Total 90 members or 90 members for new treatment. Now coming to conventional treatment, 40 are favorable, 70 are not favorable, total 110 members. Total, according to the favorable or not favorable concept, total are 100 members are favorable and 100 members are not favorable. How many rows? Only 2 rows and 2 columns. We are not going to consider the total values. Only 2 rows and 2 columns. That means how many observed frequencies? 1, 2, 3, 4. 60, 30, 40, 70. The observed frequencies are 60, 30, 40, 70. We have to find out expected frequency. We have to find out expected frequency from method 3. To find expected frequency, we have a formula which is corresponding row total into corresponding column total by grand total. If I want to find expected frequency corresponding to the observed frequency 60, that means this one. This one corresponding row total is 90 into corresponding column total is 100. 90 into 100 by 200, we are going to get 45. Now coming to 30, I want to find out expected frequency corresponding to the observed frequency 30, which is corresponding row total 90 into corresponding column total 100 by grand total, which is also 45. Now coming to 40. Corresponding row total 110 by corresponding column total 100. 110 into 100 by 200, which is 55. Similarly, 110 into 100 by 200, which is also 55. So these are the observed frequencies corresponding to the these are the expected frequencies corresponding to the observed frequencies. After getting observed and expected frequencies, these are the observed frequencies and these are the expected frequencies we have calculated by using method 3 formula. Next, what is chi-square formula? Sigma OI minus EI whole square by EI. To evaluate this value, first we have to find OI minus EI whole square. This is OI minus EI whole square. 60 minus 45, which is 15. 15 square 225. 30 minus 45 minus 15 whole square 225. 40 minus 55 minus 15 whole square 225. 70 minus 55 minus 15 whole square 225. And to evaluate this value by EI, 225 by 45, which is 5, 225 by 5, 45, which is 5, 225 by 55, which is 4.09, 225 by 55, 4.09. But in the formula we have sum. If we add all these terms, we are going to get 18.18. But in the test of hypothesis procedure, we are going to discuss about all the 5 steps. The step 1, null hypothesis, which is defined as H0. We are going to set up there is no difference between observed and expected frequencies. And alternative hypothesis, which is denoted by H1, that means there is a difference between observed and expected frequencies. And level of significance alpha is 0.05, which is standard. If it is not mentioned in the problem, we can take directly level of significance alpha is 0.05. Now we can choose chi-square 0.05 at r minus 1, where r is number of rows and c is number of columns. At 1 degrees of freedom 3.84, which we have seen in the previous problem. And step 4, the test statistic chi-square, we got it 18.18. Mod chi-square we are going to take, because if there is any negative, we are going to take as a positive. And chi-square alpha, we got it 3.8 something. So according to the conclusion, the mod chi-square value is greater than chi-square alpha. So according to the statement of test of hypothesis procedure, we are going to reject the null hypothesis. Actually, what is null hypothesis? OI equal to EI. That means there is no difference between observed and expected frequencies. But what we have concluded, we are rejecting the null hypothesis. That means this is not the correct. That is, there is a difference between observed and expected frequencies. So this is the method 3 problems on chi-square test. And we have 3 exercise problems in method 3. Here also same, 2 rows and 3 columns. Total values are not given, even though we can do 2 rows, clerks, Pepsi, thumbs up, and clerks, teachers, officers. So 2 rows, 3 columns. We can find out chi-square alpha at 2 minus 1 into 3 minus 1 degrees of freedom. That means chi-square alpha at 1 into 2 degrees of freedom we can choose from the chi-square distribution table. Now coming to the second problem also, here we have 2 rows and 2 columns. We are not going to consider the total values. Only 2 rows and 2 columns. Now coming to third problem, here 2 rows, first row, second row, first column, second column, third column, fourth column, 2 by 4. So chi-square alpha at r minus 1, 1 into c minus 1, 3 degrees of freedom. So we are going to choose chi-square alpha value at 3 degrees of freedom from the table. Remaining process is same for all the 3 problems. Now what I am going to conclude in the chi-square test is, the chi-square formula is sigma OI minus EI whole square by EI. For all the 3 methods, this formula is same to test whether there is any significant difference between observed and expected frequencies. But only the change is how to find the expected frequencies. I told you that we have 3 methods. Method 1, method 2 and method 3. In method 1, we are going to calculate expected frequency by using average of all observed frequencies. In method 2, we can find out expected frequency by using either binomial or Poisson distribution, depends on the problem. And method 3, we can find out expected frequency by using corresponding row total into corresponding column total by grand total. This is only the difference for all the 3 methods in chi-square test. Okay, thank you.